So, today I will talk about using Taylor series and explaining how this Euler formula makes sense. So, e to the I theta equals cosine theta plus I sine theta. They don't look related at all or really clean, but using Taylor series and the definition of them, we can explain and see how they actually make sense. So these three major Taylor series identity, e to the x, sine x, and cosine x, equals these. So it's good to memorize these in order to solve some Taylor series related questions. So let's begin. Using rule of substitution, I can say that I theta equals x. So by using this, I can say e to the I theta equals e to the x. So using the substitution, we can say this Taylor series equals, so e to the x equals e to the I theta equals 1 plus x, which is I theta because we substituted. So I can expand like this, keep plugging I theta into x. So this is the new formula, new definition we got using substitution and the Taylor definition of e to the x. So we can say that this continuing series equals cosine theta and the sum of cosine theta and I sine theta. So here, so because we got e to the I theta, let's write down what cosine theta plus I sine theta equals to. So first, cosine theta, because cosine theta is same format of cosine x, so this can be just the same definition of cosine x, but just writing theta instead of x, which is this. And then I sine theta equals the Taylor series, Taylor definition of sine x, just writing theta instead of x, and times I to the each term. So which will be like is this, and here. Now, so we got cosine theta and I sine theta. So sum of these equals this, which is e to the I theta. So let's add them together. So the Taylor definition of cosine theta right here plus Taylor definition of I sine theta, which is these, come down like that. So actually getting rid of the parentheses and just putting them down will be like 1 plus, and it keep goes. So this continuing series is the sum of cosine theta and I sine theta. So this must equal e to the I theta, because according to the Euler's formula right here. So up here we got e to the I theta, the definition. So if we move that down, e to the I theta equals this series. And if you use the definition of I, imaginary number, which is square root of -1, we can rewrite this whole formula as this. So this looks very familiar to me. So okay, it's right here. So this, the whole series, resembles exactly to this formula right here, which was the sum of cosine theta plus I sine theta. So by using Taylor series, the definition of the Taylor series, the whole thing, we figured out and we explained that e to the I theta equals cosine theta plus I sine theta. So at the first time when we first looked at it, we had no idea that this I e to the I theta and sum of cosine theta and I to the sine theta will equal. It didn't look very related, but by using and expanding using Taylor series, we defined here that they actually, the e to the I theta here and the sum of cosine theta and I sine theta actually equals to each other. So this makes sense. This is the correct, and we just justified and explained how they actually equal to each other. Thank you.